Hello everyone, this is Gubbi online classes for Ncert 10th standard and Cbse 10th standard for mathematics and science. So in this session we are going with the chapter light. This is session 6. So in the previous session we had discussed regarding the rules for drawing ray diagrams for concave mirrors. So the 4 rules what we had discussed in the previous class, I am going to just recapitulate everything once again with those reminders in our mind. We will get into today's class, which is very important. So if you want to master the ray diagrams of concave mirrors, this is the class for you. So in today's session, we will be going with some 6 ray diagrams connected to concave mirrors, how the images are formed when the position of the objects are changed. Continuously when we change the position of the objects, the images are going to change, in the sense with respect to the nature of the image and with respect to the size of the image, the things are going to change, how they change and with what conditions they go on changing, what is that changes happening from one ray diagram to another ray diagram. That is the observation required for you students. So therefore we will revise the rules one. So first rule number 1, yesterday's class I had told you that whenever a light ray incident on a concave mirror which is travelling parallel to the principal axis, after reflection it will pass through the principal focus. This is rule number 1. We will go with rule number 2. If the light ray is passing through the principal focus and striking the concave mirror, after reflection the light ray is going to travel parallel to the principal axis. This is rule number 2. So rule number 1 and rule number 2 are just reverse of each other. So if light ray travels parallel to principal axis, it passes through the focus. If the light ray passes through the focus, after reflection the light ray is going to travel parallel to principal axis. Third point, if a light ray is passing through the center of curvature of a concave mirror, after striking the mirror, that is after reflecting from the mirror, it is going to retrace its own path, in the sense it is going to go back again through the center of curvature itself. That is, it is going to bounce back. So this is rule number 3. So rule number 4, if a light ray is obliquely incident on the concave mirror which is not parallel to the principal axis, then at the particular point that is called pole of the mirror, then the angle which is formed between the incident light ray and the principal axis, at the same angle of incidence it is going to get reflected and go back, creating an angle which is the angle of reflection, obeying the laws of reflection, that is angle of incidence is equal to angle of reflection. So these are the 4 rules you have to remember before entering into drawing ray diagrams. So this is very important. So each and every ray diagram, what you have to observe is where the object is placed, where the image is formed, and position of the image and size of the image. So these are the 4 particular things you have to observe very keenly for each and every ray diagram. So I will repeat this. For the ray diagram, to analyze the ray diagram, 4 observations are required. One is where the object is placed. Second point is where the image is formed. Third point is what is the size of the image which is formed and what is the nature of the image. So these are the 4 factors you have to observe while I am going with the ray diagrams for each and every ray diagram what we go with today. So today totally we are having 6 ray diagrams, so it will flow one by one. So very keen observation is required. Really you will enjoy this session. Okay, let us go with the first ray diagram. So object is at infinity. So imagine we have a concave mirror and the object is placed at infinity. So let us go with the concave mirror now. So this is the concave mirror, so which is silvered at the outer surface so that it is reflecting at the inner surface. This is the pole of the mirror. This is the center of curvature of the mirror. So let us join the center of curvature and the pole of the mirror and extend it on both sides. So this is pole of the mirror. So extend it on both sides and this becomes the principal axis. Okay, now here the object is placed at infinity. Infinity in the sense it is beyond C, more than that. No, it's not beyond C, it is more than that. So the object is placed at infinity. I can take it like this. The object is somewhere here at infinity. So here, for any particular ray diagrams from a point source, because the object is very far away from us, so therefore it should be considered as a point source. But for writing the ray diagrams, the object which is placed at infinity, we will consider as a ray of light. Let us take it as A, and let us take this point as B. So the object is at infinity. So to draw a ray diagram, minimum number of light rays required is 2. 2 minimum light rays are required. So one light ray will take it from point A. Let us imagine these light rays are coming from infinity and they are exactly parallel to the principal axis. So the light rays which are coming from a larger distance will be parallel to each other. They are parallel to each other. Okay. So this light ray is coming from point A and it is traveling towards the mirror exactly parallel to the principal axis. Now, so according to the rule 1, when a light ray travels parallel to the principal axis, after reflection, it should pass through the principal focus. Now, where to locate the principal focus? Very simple. Locate at the exact midpoint of the center of curvature and the pole of the mirror. So this is the principal focus. The light ray after reflection from the mirror passes through the focus, that is principal focus. Passes through the principal focus according to rule 1. So now we will consider another light ray which is from point B. It is also traveling parallel to the principal axis, exactly parallel to the principal axis here. So now according to rule 1 again, the light ray after reflection, it passes through the principal focus. So here the two light rays, that is the light ray coming from point A and the light ray which is coming from point B, after reflection both the light rays are passing through the principal focus. So, where is the image formed? This is the question now. The image is formed at the point where the two reflected light rays meet each other. So here, the two reflected light rays are meeting each other at the principal focus. Therefore, the image is formed at the principal focus itself. So, now we'll go with the position. So what is the position of the image? The position of the image is at F. It is at focus. The object is at infinity. Therefore, the image formed is at F. So now, what is the nature of the image? So we'll write the nature, how it is, how big it is, how small it is, right? Whether it is a real image or a virtual image. So all these things we write in the nature of the image. Now, as these two light rays, reflected light rays, are actually meeting at a point. If two light rays actually meet at a point of the reflection, 100% at that point the image which is formed is a real image. A real image is formed where after reflection the light rays actually meet. So this image formed here is a real image. It's a real image, right? So real images, we know that they are always inverted, so therefore it is an inverted image. A real image is always inverted, an inverted image is always a real image. Both are true. Both are true. So now, what is the size of the image? So size of the image is highly diminished. It is point sized. Point sized or highly diminished. Is highly diminished. So this is the ray diagram of a concave mirror when the object is placed at infinity. Right? So position of the image is at F. Nature of the image is a real image. Real images are always inverted, and the size of the image is point size, and it is highly. That means it is highly diminished. Now, we will bring this image which is kept at infinity towards the mirror and keep it beyond C, not at C, little bit far away from C. So then we will see what is the position, nature, that is position and nature of the image. Let us go with the next ray diagram. So object is beyond C. Let us go with this. So imagine a concave mirror, so which is silvered at the outer surface, so therefore it is having inner reflecting surface. This is the pole of the mirror, this is the center of curvature we will take. So we will draw a line through C and P which makes the principal axis. Let us take the midpoint of between C and P, that is called principal focus. Now the object is placed beyond C. So beyond C the object is placed, so it is a bigger object. Therefore we will represent that object by a ray, which is where here A is called the head of the image and B is called the tail of the image. Now we will draw the ray diagram of this object AB when it is placed beyond C. So now let us take two light rays. So to draw a ray diagram we need minimum two light rays starting from that point. So one light ray we will take it from point A, which is travelling exactly parallel to the principal axis. So here, according to the rule 1, when the light ray starts travelling from a point and parallel to the principal axis, after reflection it should pass through the principal focus. So after reflection the light ray will pass through the principal focus. So this is the light ray which is passing through the principal focus. Now let us go with another light ray. So let it start from point A, and from where it should go. Remember this, the light ray, let the light ray pass through the principal focus of the mirror. So here the light ray is travelling through the principal focus of the mirror according to the rule 2. After reflection the light ray should travel parallel to the principal axis. So the light ray travels, hits the mirror, gets reflected, and it starts moving parallel to the principal axis, that is parallel to the principal axis. Now here at this point, this is the principal focus. Here at this point we can see, so this is the reflected light ray and this is the reflected light ray. So this is the point where actually the two light rays meet each other. The two light rays meet at this point. So this is the reflected light ray comes like this, gets reflected, it goes like this. Light ray comes like this in this direction, after reflection it goes like this. So both the light rays after reflection they are meeting at this point. So here, as I told you earlier, the image is formed where the two light rays actually meet. So here the two light rays actually meet at this point. So therefore this image will be like this. This is A dash and this is the B dash. So this image is formed here in this manner. So this is the image of the object which is placed beyond C. Now let us go with the size of that is position. First one is position. So now where the image is formed, the image of this object is formed between C and F, exactly in between C and F. So between C and F, the image is formed between C and F. So what is the nature? So what is the nature of the image? So here, as the two light rays which are reflected actually meet at a point, so therefore these images are real images. So it is a real image, and we know that a real image is always inverted. Real and inverted, okay. Real and inverted image. So now, what is the size of it? What is the size of the image? So here, when we compare the size of the image with the size of the object, we can see that the size of the image is less than the size of the object. So it is diminished. It is not highly diminished, just it is diminished. Okay, we'll go with the next ray diagram. So here we are bringing the object nearer and nearer to the mirror. So first in the first ray diagram it was placed at infinity. Now we have brought it beyond C. Now we will take the same object and keep it at point C. That is, at C we will place the object. Let's see what happens. Object is at C. Now, consider an concave mirror. This is silver at the outer surface, hence it is reflecting at the inner surface. This is the pole of the mirror. This is the principal axis. This becomes the center of curvature, and this is the principal focus. When drawing ray diagram, see that this distance is equal to this. Maybe you can take 2 centimeters, 2 centimeters, or 3 centimeters, or 3 centimeters, something like that. You can make equal distance. Now, the object is placed exactly at C. So let us take the object as AB. So AB is the object here. Okay. Now let us take 2 light rays starting from point A. So let us make one of the light ray travel as usual parallel to the principal axis. So it is traveling parallel to the principal axis. So according to the rule 1, the light ray which is traveling parallel to the principal axis after reflection passes through the principal focus. Let us pass through the principal focus. The light ray after reflection is going in this direction. Now, where to pass the another light ray, that is second light ray, where to pass. So now, usually we will do like this. We will take another light ray from point A and let us make it to pass through the principal focus. So the light ray is second light ray is passing through the principal focus. So after reflection at this point, the light ray is going to travel parallel to the principal axis according to the laws of the rules what I told you earlier. So here, this is C, and the 2 light rays are actually meeting at this point. At this point, the 2 light rays meet. So that means the image is formed here. That is here. So this is A dash and this is B dash. So now, if you exactly analyze, we can see that the 2 light rays after reflection meet at this point exactly below C. Below C means the image is also formed at C itself. So let us write the position. The position of the image is at C. At C. So size of the image is. Now when we compare this, when we compare the that is length of AB with the length of A dash B dash, that is image, the size is same as object. Same as object. That's very important. So then we'll go with the nature of the image. So here we can see that the 2 light rays, one is this light ray, another is this light ray, that actually meet at this point. So if 2 light rays, if they actually meet at a point, then we see that the image is formed at that point, and that image will be a real image. If the image is a real image, 100% it is inverted. So it is real and inverted. It is real and inverted. So now, what is the size that we have written? That is same as object. So this is what happens when the object is at C. So if you analyze the things, if you analyze, so it was at infinity, the object was formed at focus, it was brought near to C, it was brought near to C, that is beyond C. The image was formed somewhere between C and F, and when it was at C, when the object was placed at C, the image was at C. In the sense, if you are bringing the object nearer and nearer to the mirror, the image is moving away from the mirror, being its size is being enlarged. So it was a point here, it was a diminished small image, now it is equal to the size of the object. See, this is the analysis, keep it in your mind. Okay, let us go with the next one. So I am bringing the object a little bit more near to the concave mirror, that is I am going to keep the image, that is object, between C and F. in the next ray diagram. So object is between C and F. Object is in between C and F. We will go with the ray diagram again. So let us consider this as a concave mirror. So which is silvered at the upper surface, and this is the reflecting surface. This is the pole of the mirror. So this is the center of curvature. So let us draw a line through center of curvature and the pole of the mirror. That becomes the principal axis. Now at center, the midpoint of C and P, that is the principal focus. Now I am keeping the object between C and F. Between C and F, and I will call that object as AB. So A is the head of the object and B is the tail of the object. Now, so in this ray diagram, two light rays have to be taken from point A. So usually what we do is one light ray we will take it from the point A parallel to the principal axis, what we have done earlier. So we will take it through the parallel to the principal axis. So according to rule 1, when a light ray is travelling parallel to the principal axis, after reflection it should pass through the principal focus. So the light ray after reflection will pass through the principal focus here. So the light ray, this is the reflected light ray, is passing through. Now, what about the second light ray where we have to pass it through? That's very important here. So again, make the light ray to pass through the focus. Let it pass through the focus of the mirror. So here, as the light ray passes through the focus of the mirror, after reflection, the light ray is going to travel parallel to the principal axis, that is according to rule 2. According to rule 2, the light ray is going to pass parallel to the principal axis. So this line is parallel to this. So now, at this point here, the two reflected light rays are meeting each other. So here the image will be formed. So this image will be like this. So this is A dash and this is B dash, A dash and B dash. So here if you observe this, the size of the image is increased when compared to the size of the object. That's very important here. So now let us write the nature and position. So position, we'll first write the position of the image. So we can see that the image is formed beyond C, it is after C. So it is beyond C. Beyond C, very important. So let us go with the size of the image. The size of the image, when you compare with the size of the object, it is enlarged. It is bigger than the size of the object. So therefore it is enlarged. Right. So then we will go with the nature. So here the two light rays actually meet at this point. They actually meet at this point, then the image is formed at this point. Therefore, the image will be a real image. Real images are always inverted. So real and inverted. So this is regarding the image, which is image of an object which is placed in between C and F. This is very important. Okay, we will go with the next ray diagram. So now what I am going to do is, I have placed the object between C and F. Now I will place this object at exactly F. Let's see what happens. Object is at F. So now imagine a concave mirror which is silvered at the outer surface, so therefore it is reflecting at the inner surface. So this is the pole of the mirror, so this is the center of curvature. So I will draw a line passing through the center of curvature and the pole. So this becomes the principal axis. The midpoint of C and P is the focus. So I am going to place the object exactly at focus. So object is at F, right? So very important, very important. Observe this very carefully. So this is A dash, A dash, and this is A and this is B. Now, how to draw the ray diagram here? So one light ray, usually what we do is we take it from A, point A, and make it to travel parallel to the principal axis. Let us do it. So the light ray starts, it starts moving exactly parallel to the principal axis. So according to rule 1, as the light ray travels parallel to the principal axis, after reflection it is going to pass through the principal focus. So this is the reflected light ray. This is the reflected light ray. So what about the second light ray? Because usually we used to make the second light ray to pass through the principal focus, but now actually the object is on the principal focus. So what about the second light ray? So no problem. So we have the center of curvature here. So now let one of the light ray pass from point A towards the mirror, such that the light ray is coming from the point C, that is center of curvature. Listen, you have to be very careful here. Select the second light ray such that in such a manner that it is traveling towards the mirror as though this particular light ray is coming from the center of curvature of the mirror. So according to the rule 3 what we have discussed, the light ray which is traveling from the center of curvature and strikes the mirror, it is going to rebound and it is going to travel in the same path. The light ray is going to come back in this direction. So these are the two reflected light rays. So these two reflected light rays, when they travel further and further and further, they will never meet each other. They will never meet each other because these two light rays are exactly parallel to each other. So here we assume that two light rays which are traveling parallel to each other for a very long distance, we consider that they meet at infinity. They meet at infinity. So we will produce this principal axis to infinity, it's imagination. So these light rays, they may meet at this infinity. So here the image will be formed. This is A dash and this is B dash. This is where the image is formed. So this image, when compared to the object, this image is highly enlarged. It's highly enlarged. It's a very big image because this image is formed at infinity. This is very important ray diagram. Let us write the position. So position of image is at infinity. It's the position. So size of image is highly enlarged. It's highly enlarged, and the nature of image is, it is as the two light rays actually meet at this point, we assume that, so therefore the image is real, and the real image is always inverted. So this is regarding the image which is formed when the object is placed at F. Now, in the last ray diagram, we will carry this object still furthermore and place it in between F and P. Let's see what happens. So this is the sixth ray diagram, right? Object is between F and P. F and P means the principal focus and the pole of the mirror, right? So let us draw the ray diagram, that is mirror, concave mirror, which is silvered at the outer surface. This is the pole of the mirror. So this is the center of curvature. This is the principal focus at the center. So we will draw a line, that is principal axis, and extend it on both sides indefinitely. Right. So now the object is placed in between C and, that is F and P. Let the object be here, somewhere here. So let us call it as A and this as B. So now from point A we have to start two light rays. One light ray which should travel parallel to the principal axis, and the second light ray should go with the center of curvature, right? So let us go with this. So this is point A. I'll write it here. Or we can do one thing. It's still more easy. Let us make this particular light ray starting from A. Go to the pole of the mirror. Move towards the pole of the mirror. So when a light ray hits the pole of the mirror, it follows the laws of reflection. So here the angle between the principal axis and this incident light ray, this angle should be equal to this according to the fourth rule what I told you yesterday. So the light ray is going to get reflected in this direction and starts moving out. So this is the reflected light ray. Okay, another light ray we have to follow. So let us take it from point A in such a way that it is such a way that the particular light ray is coming from the center of curvature of the mirror. So here a particular light ray, if it travels from the center of curvature of through the center of curvature of the mirror and strikes the surface, then we say that it is going to rebound or it is going to retrace its own path. So this light ray after reflection is going to travel in this direction. So here when you compare both the light rays, both are diverging light rays. They will never meet each other even at infinity. Even at infinity the distance between the two rays will be still more. In the sense they will never meet each other. So then how can we say that the image is formed in this case? So to form an image in this case, we have to go with a simple idea. We have to extend these light rays backwards. Extend these light rays backwards. So here the two light rays are going to meet each other. In the sense, from this point it appears as though these two light rays are coming out. So here we say that the image is formed at this point. So if you draw a line above the principal axis, this will be A dash and this will be B dash. So it is formed, the image is formed beyond the mirror. It is behind the mirror. If the image is formed beyond the mirror, we say that that's not a real image, because actually two light rays are not meeting each other to form the image. So it is a virtual image. So let's go with the position. So according to the position, it is beyond the mirror. It is beyond the mirror or behind the mirror. So let us go with the size. So when you compare the size of the image with the size of the object, it is just enlarged a little bit more than the object. It is enlarged. Right. So then we will go with the nature. So the nature of the image is, here the image is formed as it is formed behind the mirror. Actually two light rays do not actually meet at that point. It appears as though the light rays meet at this point. It appears as though it is meeting. So therefore the image is virtual. So all virtual images are direct. Virtual and direct. So this ray diagram is very important, because it is used in some type of working of, to understand the working of some type of mirrors. So this is very important. So I hope here all the 6 ray diagrams completes. So all these 6 ray diagrams are very important. You have to practice these ray diagrams along with the question will be asked in your examination for 3 marks. Draw a ray diagram of a concave mirror when the object is placed at F. Write the nature, size and position of the image. So this will be the question. So you have to draw the ray diagrams and then you have to mention the nature, size and position. So this is very important. You have to practice all the 6 ray diagrams. And at the end of this, I am giving you a homework. So what you have to do is, you have to frame a table like this. Frame a table like this. So in the first column, object, next is size, next is position. So make 4 columns like this, where the object is placed, where the image is formed, what is the size of the image, and what is the position of the image. Right? So all these 4 you have to fill for all 6. First one, second, third one, 4th, 5th and 6th. So all the 6 we have to do. So for example, object is placed at infinity. So image, where it is formed, what is the size of the image and what is the position of the image. So like this you have to fill all the 6. Frame the table for this and send me through WhatsApp in tomorrow's class. Right? So I hope you enjoyed the class. It was a very important class. It's the heart of the chapter. You have to remember the theory. If you are well versed with ray diagrams, problems will be very easy for you. It will be dead easy for you. So sign convections for spherical mirrors and ray diagrams. If you are masters in this, then you will be good at numericals. Right? So if you have any doubts, please send it through the WhatsApp so that I will clear it. Stay home, stay safe and keep learning. Thank you very much.